We're going to continue with the next section of our study guide, which is polynomial division. Now, what I'm going to do is I'm going to go ahead and apply synthetic division instead of long division to these problems. That will save us some time. Let's do that. Problem number 8, we're asked to divide this polynomial by x plus 8. So with the synthetic division method, just keep in mind that it's just a shortcut method for helping us to find what we need to find. It's very quick, and it really beats doing the long division sometimes. So the first thing I'm going to do is I'm going to go ahead and set it up. So the setup for that will look like this. I'm going to take the divisor, x plus 8, and I'm only going to use the constant, but I'm going to use the constant's opposite. Since it's plus 8, the opposite of that constant is going to be negative 8. And that's going to be on the outside of my division house. And then we're going to take the coefficients and the constant of the dividend, which is this long polynomial string, and we're going to apply those and put them up underneath the division house. So for this first coefficient, for the x to the fourth, and notice that these are in descending order: the fourth power, third power, second power, first power, no power. So the coefficient of x to the fourth, since I don't see any number there, it's a 1. So I'll put 1 here. The coefficient for the next one is 14, so it goes next. 43 is the next. Negative 37. And lastly, my constant 31 goes here. Okay, so first step, you may remember steps, is to drop that first coefficient straight down, the 1. And from there, I multiply 1 times negative 8, which is negative 8, and I put it right here next door. And then I actually combine these two, so I'm adding that together. 14 and negative 8 gives me 6. I repeat the process. Now 6 times negative 8 is negative 48. I combine these, and I'll end up with a negative 5. Repeat the process. Negative 5 times negative 8. A negative times a negative is a positive 40. And I combine those. That will leave me with a positive 3. Repeat the process again. 3 times negative 8 is negative 24. And when I combine these, I end up with 7. Now this last number is going to be my remainder. So that's always your remainder. And now we're going to actually pull these values off of or out of the problem, and we're going to actually fill in the variables. So we'll put the variables back in. Notice up here we took the variables out and we only use the coefficients. Now, since we got some answers, we're going to put the variables back in. However, when we start putting the variables in, we need to go down 1 less on our exponent. And this is what I mean. So I'm going to bring my 1 down. So my first coefficient for the answer is 1x to the third. So I drop down by 1 exponent. Instead of to the fourth power, it's to the third power. The next one is 6, so it's a positive 6, so plus 6x to the second power, minus 5x to the first, and I don't have to put the first power there. And then 3, since it has no exponent at all, because this is third, second, first, none. So that'll be plus 3, that's my constant. And the way I write my remainder is I write my remainder of 7 over my divisor of x plus 8. And what I'm going to do lastly is take this coefficient of 1 off the front, because remember, if there's a 1 there, you don't have to write it. It's assumed to be there if you see no other number. So here is our solution for number 8. And we use synthetic division to do it. Let's do number 9. Same process. Here I've got 3 plus x. I'm using the constant only, but I'm using the opposite of the constant, which is a positive 3, so I'll use a negative 3. So we've got negative 3 on the outside, and then I use the coefficients of this polynomial string for the inside. But notice that it's out of order. In other words, it's not going in descending order, starting with the highest exponent, so I'm going to put it in order because it'll be easier to see what goes where. So in this case, I see the highest is x to the 5th, so I'm going to rewrite this as x to the 5th plus x to the 4th minus 9x to the 3rd minus 16x to the 2nd minus 24x minus 17. So all I did was rewrite it. And I still have my 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 terms. And I've put them in descending order. 5th power, 4th power, 3rd power, 2nd power, 1st power, no power. Now I can go ahead and pull the coefficients off. So the first coefficient is 1. The next one is 1. This one is negative 9, negative 16, negative 24, and negative 17. Okay, let's follow the same process. First thing I'm gonna do is just bring this one down and then start multiplying by negative 3. 1 times negative 3 is negative 3. When I add these, I get negative 2. Negative 2 times a negative 3 is a positive 6. This will leave negative 3. Negative 3 times negative 3 is positive 9. Combine these, I get negative 7. Negative 7 times negative 3 is positive 21. Combine those, I get negative 3. Negative 3 times negative 3 is positive 9. Combine these and I get negative 8. So here's my remainder. Remember that last value is always your remainder. Now let's go ahead and pull these values out of the problem, put the variables back in. But of course, remember, instead of the first variable being to the 5th, it'll be to the 4th power. So 1 x to the 4th, negative 2 x to the 3rd, negative 3 x squared, negative 7 x, and negative 3 as my constant, plus my remainder of negative 8 over my divisor of, I'm going to rewrite this as x plus 3. And I'm going to take this off. And here's my solution. Lastly, number 10. We'll use the same process. So I've got, instead of negative 1 on the outside, it'll be positive 1 on the outside. And let's go ahead and pull our coefficients. The highest one is n to the 4th, and that's a 1 in front, so that goes there. N to the 3rd is a negative 1. Now, notice there's no n to the 2nd power on this one, but we still have to account for that position, so we use a 0 as a placeholder for that. So this is the 4th power coefficient. This is the 3rd power coefficient. I don't have a 2nd power, so my 0 will serve as a placeholder. My 1st power coefficient is negative 2. My constant is negative 6. Okay, let's go ahead and drop this one down. 1 times 1 is 1. When I combine those, I get 0. 0 times 1 is 0. Combine those, I get 0. Same here, 0. Combine these, I get negative 2. Negative 2 times 1 is negative 2. Combine these, I get negative 8, which is my remainder. Now look at this right here. This is a little bit different. But we still have to pull those off. The only thing is we don't use 0 as a coefficient. So that means for those positions, we won't have a term. But I start with my 1, and in this case it's n. My highest exponent was 4, so I'm going to drop down to the next highest, which is 3. So 1 n to the 3rd, no n to the 2nd, because it's 0. No n to the 1st, because it's 0. But then my constant. I'm going to take this off, and I'm still going to write my remainder as plus the remainder of negative 8 over my divisor of n minus 1. And this is the solution for number 10. All right, let's move on to the next section, which is composition of functions, starting with number 11.